Welcome to The Explainer. Today we're taking a massive journey back in time, tracing our universe from absolute pitch-black darkness to the literal birth of light. We're going to focus specifically on exactly how the very first stars formed out of essentially nothing, and how they laid the groundwork for, well, the whole shebang, everything we know today. Let's just dive right in.
So drop right into the cosmic dark ages with me for a second. For hundreds of millions of years, if you were to look out into space, you'd see absolutely nothing. No galaxies, no twinkling stars, zero planets. The universe was just this endless expanse filled with massive, completely invisible clouds of simple hydrogen and helium gas just drifting in total darkness.
Section 1. The Cosmic Dawn. The Dark Age ends.
Now, what's really interesting about this slide is the intense physical battle happening here. That quiet darkness, it couldn't last forever. Gravity, which is basically the most relentless force in nature, slowly started pulling these massive gas clouds together. And it wasn't some sudden pop, it was a grueling cosmic tug of war. On one side, you have gravity constantly pulling hydrogen and helium inward, trying to crush it into a tighter and tighter ball. But on the flip side, the internal pressure of the gas itself is fighting that collapse, pushing right back out.
But eventually, gravity overpowered that outward pressure, and those gas clouds started to collapse. It's kind of like a giant vise tightening. The core shrinks, which creates incredible friction and density. And as it shrinks, the temperature skyrockets to unimaginable levels, setting the stage for a fundamental change in the very nature of the gas itself.
We are literally talking about temperatures of millions of degrees here. This isn't just a roaring campfire. It is a localized inferno so intensely hot that it actually alters atomic structures. And this immense, escalating heat was the absolute #1 prerequisite for what comes next to finally break the darkness.
Which brings us to Section 2. The birth of fusion. Gravity takes control.
Right, so because the core was crushed by gravity to those millions of degrees we just talked about, the hydrogen nuclei inside had nowhere left to go. They smashed into each other, fusing into helium. This reaction, nuclear fusion, releases just a staggering, mind-blowing amount of energy. And the moment that ignited, the very first light in the history of the cosmos burst forth, instantly flooding the surrounding universe with brilliance, a true turning point in nature. Moving to Section 3, Early Universe Giants, the first stars.
So the crucial point is just how wildly different these first stars were. They were true behemoths, formed from massive, pristine clouds of pure hydrogen and helium. And because they were so insanely huge, they burned hotter and shone way brighter than our own sun. But there is a catch. They had a surprisingly short lifespan. While our sun is going to live for about 10 billion years, these early giants burned through their massive fuel supplies so aggressively that they only lived for a few million years. Honestly, in cosmic terms, that is just a blink of an eye.
Let's look at Section 4, Element Factories, Forging Elements.
What were they actually doing inside their cores during those few short million years? Well, these massive stars were essentially acting as high-pressure furnaces. Heavy elements, we're talking carbon, oxygen, silicon, iron, were being forged deep inside through that continued nuclear fusion. Remember, the universe started with just hydrogen and helium. Without these massive early stars acting as cosmic factories, the exact chemistry needed for rocky planets like ours, and the carbon and oxygen needed for, well, living organisms like us, they simply couldn't have existed. No way.
Okay, let's dive into this next part, Section 5, the first supernovae, a new generation. So when that initial hydrogen and helium fuel finally ran out, that outward pressure we talked about earlier, it just stopped. Gravity won the final battle in an instant, violently crushing the star's core in a fraction of a second, which resulted in a massive supernova explosion. And this sheer violence acted as the ultimate cosmic delivery system, blasting all those newly forged heavy elements outward across the vastness of space.
Now, those scattered elements didn't just disappear into the void. They mixed into the surrounding gas clouds, totally enriching the cosmic environment. And then, those enriched clouds eventually collapsed again to form second and third generations of stars. But this time around, because of all those heavy elements, these new stars were surrounded by swirling disks of debris that clumped together into planetary systems. And yep, billions of years later, one such enriched star system formed, and one of its rocky planets, Earth, would eventually become home to life.
I really want to bring this history right down to you. Every single atom heavier than helium has its story rooted in the lives and violent deaths of these ancient stars. The calcium in your bones, the iron in your blood, literally the silicon in the device you're using to watch this explainer right now. All of it was forged in the fiery core of an ancient star that exploded billions of years ago. You are, quite literally, made of stardust.
Which leaves us with a pretty incredible question to ponder. If those first stars had never formed, the universe would just be a dark, cold mist of hydrogen and helium forever. So, what do you think? Was life an inevitable consequence once those stars began churning out heavier elements? Or is Earth's story and our very existence just an extraordinarily rare cosmic accident? Keep wondering about that one. Thanks for joining me for this explainer, and we'll see you next time as we jump into the formation of the very first galaxies.